Hi, this is Mezh.
And this is Katie.
And we're doing a video about the role of NAD in biological oxidative reactions.
In this experiment, we performed an oxidation reaction on a number of potential substrates using an extract from a beef heart to see the dependence on NAD+ as the electron transporter.
FADH2 is reoxidized by coenzyme Q and cytochromes. In this experiment, as an alternative, we're going to be using an electron acceptor 2,6-dichlorophenyl idafoam blah blah blah, DCIP will be used. This effectively shortcuts the pathway. DCIP acts by accepting electrons from FADH2 and in the process changing color from blue, oxidized DCIP, to colorless, reduced DCIP. In this way, the extent of oxidation can be easily observed, and we just have to measure the time taken from it to go to blue to colorless, and we'll know the extent of oxidation. In this video, you can see Katie cutting up the beef heart, and this is because the beef heart is a good sample to use because it has a lot of mitochondria in it. Look at her go, chopping away.
In every experiment, controls are needed. For this one, we used 4 controls: DCIP, DCIP and NAD, DCIP, NAD and melanate, as well as DCIP and melanate only. We use these controls as a baseline for this experiment. Where the reactions occur within these tubes, we'll be able to show if everything is right and we didn't screw anything up, also known as experimental error. Which is what we're trying to avoid here.
That is why I'm putting care into these tubes as
You go, girl.
filling them up. Woo-woo!
In some of the tubes at 4 minutes and after, you can see a little bit of colour change that shows that some of the oxidation is actually working and our experiment is working. Yes!
Each of these, so we test NAD by itself and we test DCIP with other things just to see that it doesn't actually have any impact on the whole experiment.
At about 4 minutes and above, you can see a little bit of colour change in some of the tubes. This actually just shows that our oxidation reaction is working and we did not screw up the experiment.
Yes, we're seeing colour change, everybody. And here we have it, folks. At exactly 7 minutes 29, we have malate, which has completely changed colour. Woo-woo! And here's a sped up video of lactate and the colour change. Thought it'd be interesting to watch.
It'll look cool when you see the video.
I'm making like I'm gonna speed it up and it's gonna show. No, we're gonna move the video, don't worry. No.
As you can see, tubes 9, 10, 11, 12, 13 and 16 were able to change colour after 26 minutes. Shows a good sign for oxidation reactions.
After another solid 10 more minutes of waiting, we can see that tube 15 has also colour changed, which is good to see.
Yay, tube 15 finally took its time.
To conclude, the results that we were expecting to get is what we got. We had lactate, malate and succinate all have successful biological reactions take place. We saw that even though a malonate worked as a competitive inhibitor on the enzyme succinate dehydrogenase, even though it was trying to compete in all of the 3 tubes in each of the substrates, we saw that lactate, malate and succinate didn't get affected at all by this, and this was because although it competes with succinate to go through, succinate works on complex 2, and so we still had the reaction and NAD still drove the electron transport chain from complex 1 and skipped complex 2 and continued. We also saw that although NAD was not present in the first tube in each of the beakers, we still saw that malates went through. This was because it didn't have to go through
The whole cycle.
The
So
whole
it can
cycle,
basically
yeah.
jump through different complexes.
Yeah, so it still went through and we still got results, which was what we were expecting. We saw that pyruvate didn't have any of the reactions go through, but this was expected because pyruvate is the substrate of citric acid cycle, so it needs to be oxidized and turned into acetyl-CoA, and it didn't have the enough substrates to go through, so because of that it didn't react and nothing happened. The controls didn't change, which is always a good thing because that is what we're comparing it to. But yeah, so overall in about a 40-minute time frame we had all of them go through. Like, we shows how slow biological reactions work in the body, and yeah, overall a very successful practical.
Go us, we didn't do anything wrong.
Yay. Thanks for watching.
Bye.